this series of videos, I want to talk about section 7.1 of Stewart's book, Integration by Parts. So in this video, I want to explain the idea behind integration by parts and give one example. Integration by parts, I want to set it up as a kind of analog of the substitution rule. How did the substitution rule work? It's kind of like the chain rule for integrals. What does that mean? We want to start with some function and find an antiderivative of it. Some function where you take the derivative and you get your original function. And when you take that derivative, you have to apply the chain rule. Integration by parts is going to be just like that, except with the product rule. So it'll be a kind of product rule for integrals. So here's the setup. We're going to let u of x and v of x be functions of x. Be functions of x, So remember what the product rule says. When you take the derivative of the product, u of x times v of x, what do you get? You get the first function, u of x, times the derivative of the second function, plus the derivative of the first function times the second function. So what does that mean? So let's say ignoring the plus c for now. So ignoring the plus c, what that means is that u of x times v of x is an antiderivative of this function. So using the indefinite integral notation, ux times vx is the integral of u of x times v prime of x plus u prime of x times v of x, all dx. We can use the properties of integrals that we know to break this up. This is the integral of u of x times v prime x dx plus the integral of u prime of x times v of x dx. So the way that this is usually written is we're just going to write u and v instead of u of x and v of x. Let me write this more clearly. So this is usually written in the following way, that we would just write this as, well, here's u times v. We can rearrange a little bit the integral of u v prime and the integral of u prime v. This is usually written as u dv, which is v prime x dx, equals u v minus the integral of v du. So we're thinking of du as u prime x dx, these parts together. So the important thing to remember here is that u and v are not variables. Remember, these are all functions of x. So let me just write that for emphasis. U and v are functions of the variable x. Okay, so when you think about integration by parts, usually what comes to mind is the integral of u dv equals u times v minus the integral of v du. So I'll pause and then show you a first example. Let's look at a first example. Let's take the integral of x times e to the x dx. So remember, what are we looking for? We're looking for an antiderivative of this function. And the way we're going to find it is we're going to find some function where you take the derivative and you need to apply the product rule, and it's going to give you x times e to the x dx using this integration by parts idea. So the way this usually works is you're given an integral that is a product of some things. you let one of those things be u and one of them be dv, so that the whole integral is the integral of u times dv. The thing that you call dv has to have the dx with it. So I'll just show you an example of how this works. So let's say u equals x, and dv is the rest, is e to the x dx. So this idea, if u is x, then just like when we were doing u substitution, du is defined to be the derivative of u with respect to x, du dx, times dx. So the derivative of x with respect to x is just 1. So du is just dx. So you start with u equals something that tells you what du is. dv is e to the x dx. So what are we looking for? V should be any function whose derivative is e to the x. So we just write down the simplest antiderivative we can think of for e to the x, which is e to the x. So integration by parts, so I'll say equals, this integral that we started with equals applying this integration by parts formula, that this is the integral of u dv, here's dv, here's u, is equal to u times v minus the integral of v du. So this is u times v, x times e to the x, minus the integral of v e to the x du, which is dx. So now we've found an integral. We started with this integral we didn't know, and we wrote it as a product of two functions minus an integral that we do know. So x times e to the x minus e to the x plus c. Okay, what are we saying? We're claiming that this function that we got from integration by parts is an antiderivative of the function x times e to the x. So we can check what happens when we take d dx of this function, x e to the x minus e to the x plus c. Well, we'll do the first part with the product rule. It's u times the dv, so we get x e to the x plus the integral of the first part times the second part, which is just e to the x, minus the derivative of the next part, minus e to the x, plus the derivative of c is 0. So this e to the x cancels with this e to the x, and we just get x e to the x. And we see that all of this works. Integration by parts gives us a way to rewrite an integral that we start with, thinking of our integral as some function of x is u, and the rest of it, the rest of the function of x, together with the dx as dv. This worked well because to go from dv up to v, you need an antiderivative of the function that's giving you dv. And an antiderivative of e to the x, we know, and it's not more complicated than the function we started with. The function that is equal to u, you're going to get a du by differentiating it. So we started with a function x that actually gets simpler when we differentiate. So this is the main idea behind integration by parts, which is a really, really powerful technique that works super well when your integral is given to you as a product of a couple of things.